This narrated PowerPoint focuses on the distance modulus formula. This is an extremely powerful and important formula for astronomers. Students sometimes have problems with it because it involves two buttons on your calculator that you might not use very often. The power of 10 button and the log button. The distance modulus formula relates apparent magnitude, called little m, absolute magnitude, capital M, and the distance, d, and as in most of the other formulas we've done here, the distance has to be in parsecs. Now, there are two different versions of the distance modulus formula on your formula sheet. The first is used if you are given the distance and either one of the magnitudes. The second is used if you are given both of the magnitudes and you need to solve for the distance. Here is a close-up of the part of the formula sheet that has the two different versions of the distance modulus formula. I'm going to highlight the both of them here in red for you. You can see that in the first version, d is inside the log function. That is why this is the version of the formula that you want to use if you're given the distance. Notice that in the second version, the distance is by itself on the left-hand side, and the two magnitudes are in the exponent, the power of 10. So the second version is the version that you want to use if you're given the two magnitudes and you want to solve for the distance. Now, again, the first of those two forms involves the log function on your calculator. And many of you may not have used your log button very often, not since your last algebra class. So let's practice using the log button. So find the log button on your calculator. In some calculators, you have to press the log button, then press the number that you want to take the log of. For other calculators, you press the number and then hit the log button. So you need to figure out which of those two cases is your calculator. So here are some examples. So try to find the logs of these four numbers and see if you get the answers that I got here. The second form, the one where you solve for distance, involves powers of 10, the exponent button, which can be either a 10 to the x button or an x to the y button, where here x would be 10 and y would be whatever exponent you're trying to put in. So let's practice. Find your calculator and using either one of these two buttons, calculate these four things and make sure that you get the same answers that I got here. Don't proceed with this PowerPoint until you've made sure that you can use both of those buttons on your calculator properly. So there are only three different types of examples for the distance modulus. All problems are one of these three cases. In the first, you're given the distance and the apparent magnitude, little m, and you solve for absolute magnitude, big M. In the second, you're given the distance and the absolute magnitude, big M, and you find the apparent magnitude, little m. And in the third, you're given both magnitudes and solve for the distance. Any problem that we do with the distance modulus formula is one of these three kinds. So the first kind, given the distance and the apparent magnitude, find the absolute magnitude. First, identify which of the two versions of the formula you're going to use. Again, if you're given the distance, then we can put it in the parentheses and then take the log of that number. That's your clue that whenever you're given the distance, you want to use this part of this version of the formula. So that's the version we're going to use for the first kind of problem. So if the distance is 100 parsecs and the apparent magnitude is 5, what is the absolute magnitude? So let's put in what we know. We know that the left-hand side is going to be 5. We don't know what the absolute magnitude is. We know that we have the number 5 multiplied by the log of 100 parsecs divided by 10 parsecs. So what we need to do is to divide 100 parsecs by 10 parsecs. This is going to give us, obviously, the parsecs are going to cancel. 100 divided by 10 is 10. So we're going to have the number 5 equals the absolute magnitude plus the number 5 times the log of 10. So if you go into your calculator, the log of 10 is equal to the number 1. So 5 equals the absolute magnitude plus the number 5 times the number 1, because the log of 10 is 1, or 5 equals the absolute magnitude plus 5. So obviously, what does m have to be equal to? If you subtract 5 from both sides, you get that the absolute magnitude equals 0. A second type of problem is, given the distance and the absolute magnitude, what is the apparent magnitude? So if the distance is 1,000 parsecs and the absolute magnitude is -5, what is the apparent magnitude? Note that we are still using that first form of the distance modulus formula because, again, we're given d. So we don't know what little m equals. We know that big M is -5. And we know that we have to add to that 5 times the log of 1,000 parsecs divided by 10 parsecs. So when we do that, the parsecs cancel, and it leaves us with 1,000 divided by 10. 1,000 divided by 10 is 100. So now we need to figure out what the log of 100 is. So just rewriting this formula, we have to take the log of 100. If you plug that into your calculator, the log of 100 is 2. So little m is going to be -5 plus 5 times 2, because the log of 100 is 2. Little m is -5 plus 10. -5 plus 10 is 5. So the apparent magnitude of this star is 5. Here's an example of the third type of problem. Given the apparent magnitude and the absolute magnitude, find the distance. So now we want to use this second form of the formula because we're trying to find the distance and we are given the two magnitudes. Now, there are two places where you need to be careful in doing a problem like this. The first is to figure out which is little m and which is big M and put them in the right order. The second thing is that sometimes the absolute magnitude is a negative number. And notice that we have a minus sign in here. So be very careful if you have to subtract, and you have to subtract a negative number. So just be very careful with that. So let's do an example where you have to do exactly that. If the apparent magnitude is 7 and the absolute magnitude is -6, what is the distance? So the distance is going to be 10 parsecs times 10 raised to some exponent, which is going to be little m minus big M divided by 5. So what's little m? Little m is 7. And then we have to subtract from that a -6. What happens when you subtract a negative number? When you subtract a negative number, it becomes a positive number. So now we have 10 parsecs times 10. 7 minus a -6 is 7 plus 6 that whole exponent divided by 5. So we're going to have over here 10 to the 13 over 5. So the way I normally do this is to go ahead and just divide what that exponent is in my calculator. So what is 13 divided by 5? 13 divided by 5 is 2.6. So to make it easy on myself and have less chance of making an error, I do this 10 parsecs times 10 to the 2.6. Right? So if I do 10 to the 2.6 in my calculator, 10 to the 2.6 is 398. So now I have to take 10 parsecs and multiply it by my 398. I come out with 3,980 parsecs. So be sure to go through all the practice problems on Blackboard. Remember that there are only 3 ways that a distance modulus formula problem can be framed. And once you understand how to do each of these 3 cases, there's nothing more to learn because any problem that you do will be one of these 3 types.